Hello, my name is Telmo Fernandia, and the title of the work I'm going to present is A Comparative Study of Using Augmented versus Virtual Reality in Collaborative Tasks. This research was conducted by my colleagues Álvaro Montero, Roberto Cuervo, and Paloma Diaz from the University Carlos III of Madrid, and Nels Newman and Anthony Steed from the University College London. The motivation for this work is to better understand how the choice of XR technology, AR versus VR, affects collaboration. In the past, comparisons between AR and VR were often biased by the technology, since each mode required different equipment. However, new headsets such as MetaQuest 3 and Apple Vision Pro support both AR and VR, enabling fairer comparison between the two modes. This is particularly relevant today. For example, co-located collaborators might use AR to augment their shared space, but switch to VR if the space is too small or crowded. Similarly, remote collaborators may work in VR, but switch to AR if they need to stay aware of the physical surroundings. This research aims to better understand how different types of XR technology, VR versus AR, might influence collaboration. Specifically, our goal is to answer questions such as: how does the choice of XR technology affect collaboration performance? How does the choice of XR technology affect the behaviors of the collaborators? And how does the choice of XR technology influence the satisfaction of the collaborators? To gain insights into this research question, we designed a within-subject study comparing AR and VR. For the study, we recruit 40 participants, organized in 20 dyads, and each dyad performed 3 collaborative tasks in both conditions, with multiple trials and time limits. Using Unity and Ubiq, a networking library for research from the UCL, we built a multi-user environment which could be deployed either in VR and AR. As equipment, we use MetaQuest 3 headsets, with the same interaction techniques in both conditions. User walk to move around, and to select, they press the trigger in the Oculus controller. In AR, participants were co-located in a space of about 3 by 3 meters. They could communicate face-to-face, and to facilitate manipulation of virtual objects, virtual hands overlap their hands. In VR, participants were physically separated, and communication was fully mediated by the system, interacting through avatars in a full virtual environment. We collected subjective questionnaires on collaboration, workload, and experience. We also record objective performance data such as completion time, success, and positions. Finally, we gather qualitative feedback and video recordings for behavioral analysis. The total experiment took about 1 hour to complete. To capture different interaction and communication styles, we designed 3 tasks derived from visual analytic scenarios, each requiring different levels of coordination and agreement. Task 1 is low coupling. Collaborators do not need to agree on the solution or to synchronize actions. We saw spheres representing companies where color, size, and position encode the data. The task is to identify nodes that match simple criteria, like the 2 highest red or the 2 smallest gray. This is an example of task 1 in AR mode.
Are the instructions up?
On the 2 smallest yellow.
Smallest yellow. This is 0.54. This is I've got 0.32.
There's another one above your head, which is
0.32.
That one is 0.24.
Okay, so we got 24 and 32. Yeah, I think.
Yeah.
Shall we click it? Yeah.
Yep.
Task 2 is medium coupling. Collaborators must agree on the solution, but do not need to synchronize actions. Here we use a network of interconnected nodes representing locations. The goal is to find the shortest route between 2 given nodes. Collaborators must agree on the final route, and both mark the nodes along it. This is an example of task 2, this time in VR mode.
So, 2 yellow.
The path, right?
I think that
I believe this
and that, yeah. It was the one that I, or maybe not.
Task 3 is high coupling. This time it requires agreement and coordination. The task is a graph coloring problem. Using a colors palette, the collaborators must assign colors to the nodes in the graph so that adjacent nodes have different colors. This requires both agreement and coordinates action, because each color assignment must be confirmed simultaneously by both collaborators.
Let's reuse the green here.
Okay. So green
C.
on C.
And then we can do yellow for B.
Sure.
The A could be red.
Yeah.
Now we present the results of the study. First, to answer the research question number 1, does the choice of technology influence collaboration performance? We analyze the correctness, percent of successful trials, and the completion times. As shown on the left, mean accuracy was nearly identical between AR and BR in task 1, and identical in the other 2 tasks. However, when we look at completion time on the right, a different pattern emerges. In the low and medium coupling task, completion times were very similar. But in the high coupling task, participants were significantly faster in AR, with BR taking about 33 seconds longer on average. To better understand this difference, we analyzed the video recordings. We observed that participants made occasional coordination and color assignment errors. These errors occur in both conditions, but were significantly more frequent in BR than in AR. To answer research question 2, whether the choice of technology influenced collaborators' behavior, we analyzed 3 measures. The first was a task questionnaire that participants complete after each condition to rate their leadership, contribution to the task, talkativeness, and degree of collaboration for each of the 3 tasks. The results collected show very similar ratings between AR and BR, with only a small difference and no statistically significant effects. The second analysis focused on the strategies used to complete the task in each condition. We analyzed the video recordings to identify collaboration strategies based on prior work on collaborative behaviors. 3 researchers annotated the main strategy used in each trial. Across all tasks, strategy used was very similar between AR and BR. Finally, we analyzed a collaboration questionnaire completed at the end of the experiment. The questionnaire measured perceived communication, collaboration, and comfort in both conditions. Comfort levels were similar in AR and BR. However, participants reported significantly better communication and collaboration in AR. Still, the difference in ratings were small. When put together, these results suggest that regardless of the levels of coupling, the choice of technology had minimal impact on the way collaboration was carried out. To answer research question 3, whether the choice of technology influenced collaborator satisfaction, we used 3 measures. First, a satisfaction rating from the task questionnaire, which showed very similar scores in AR and BR with only a small difference in the high coupling task. Second, the NASA TLX showed a slightly higher workload in BR, particularly in mental demand. Third, the preference questionnaire showed that participants rate AR as more efficient and slightly preferred it overall, although the differences were again small. While there was no overall consensus, participants expressed a strong individual preference in the interviews. The main finding is that the results suggest that the choice of ECAS mode has minimal impact on the collaboration. This finding is especially relevant today as modern headsets support both modes. Rather than one mode being universally better, collaboration may benefit from allowing users to choose based on their preference. Some may prefer AR to stay connected to the real world, while others may prefer VR for greater focus. We also found that high coupling tasks were performed worse in VR, likely due to synchronization difficulties. In AR, participants could see their partner's full body, while in VR they rely on avatars, which may reduce action awareness. This suggests that improving awareness on partner actions is important for highly coupled collaboration in VR, although more research will be needed. Finally, the study highlights the importance of spatial behavior in immersive collaboration. In VR, users may restrict their movements due to limited awareness of their physical surroundings. And in AR, participants move more freely and serve space more actively, although this sometimes leads to collisions. To conclude, our results suggest that device and interaction mechanisms dominate over other XR features. When these are the same, collaboration appears large and affected. Future work should test other collaborative tasks, especially those requiring spatial precision or strong non-verbal cues, and examine the roles of avatars, environment, and interaction design. Finally, future research could explore hybrid communications, such as collaboration between avatars in AR.